Differentiation. Stationary points. Given a curve, y equals x cubed minus 6x squared plus 9x plus 1. I'm going to label this point as A, this point as B. Point A is called a local maximum. Point B is called a local minimum. We call them local because over the entire curve it isn't the maximum point. But in the range either side of that point it is a maximum. Normally when we're talking about it we don't bother including the word local, but we should really. So point A is maximum, point B is minimum. The gradients of these two stationary points are 0. If you think about the gradient of them, it doesn't matter whether it's a maximum or it's a minimum, the line of the gradient is going to be flat, and that tells you that the gradient of them is going to be 0. Look at an example. Find the coordinates of the stationary points of y equals x cubed minus 6x squared plus 9x plus 1. Well, to find the stationary points we know the gradient is 0, so we'll find the gradient function dy by dx. That gives us 3x squared minus 12x plus 9, and that equals 0 at the stationary points. So we can simplify that quadratic by dividing through by 3. We get x squared minus 4x plus 3 equals 0, and we can factorise that bracket. The x squared will be x and x, the 3 will be 3 and a 1, and they're both going to be negative. So that gives us two answers, x equals 1, x equals 3. But it asks us to find the coordinates. To find the coordinates I need to know what the y values are. So to find the y values I look at my original equation, y equals x cubed minus 6x squared plus 9x plus 1, and I sub in 1, I get 1 minus 6 plus 9 plus 1, so I get 5, and I sub in 3, I get 27 minus 6 times 9, 54, plus 9 times 3, 27, plus 1. So y equals 1. That gives us 2 points, 1, 5 and 3, 1. We know looking at the diagram that the first one is A, so we've got A as 1, 5 and B as 3, 1. A point of inflection, we're going to be interested in the fact that we can have a gradient of 0 that isn't a maximum or a minimum because it's a point of inflection. Point of inflection is just a change of the curve from concave to convex. So we're going to look at it from a stationary point of view. We're going to say it's a stationary point which is neither a maximum nor a minimum. For example, a special cubic, y equals x minus 1 cubed plus 3. It's going to go and the gradient is going to be 0, but it's neither a maximum nor a minimum. That's a point of inflection. They're not the only points of inflection. You can have points of inflection that don't have a gradient of 0, but having a gradient of 0 doesn't necessarily mean it's a maximum or a minimum. Thank you.